For today's seminar, I wanted to do a summary of this amazing event. I was very lucky to be invited to. Peter was also invited, the Berlin Robotics Summit. I'll explain a little bit more about what it was all about. This is also a practice for me because we came away from this summit completely overwhelmed with all of the discussion, and so one of the ideas is we're going to periodically present our summaries of it, and so in effect you are all guinea pigs as well, and there may be some side effects or symptoms of being guinea pigs of an experimental talk. So this was a special event. It was finished 3 or 4 weeks ago, and I want to give a fairly informal, personal sort of anecdote type story of how it occurred. And so usually how these things start is you get an email out of the blue, totally out of context, which suggests or asks you whether you want to come along to this amazing sort of once in every 5-year event. And this year it's been good. There's been a few of these, and usually the answer is, if it's at all feasible, is yes please, you drop everything else to try and go. And there's another one that Nico and I are very happy to get more recently. So I'll tell you a little bit about what these events are. So there's some history to this event. This event was first held in, I think, 2011 in Berlin. I don't know, Peter, if you were at that one?
No,
okay.
the opposite one.
You're one of the more recent ones. So it's been held 10 years ago. There was a more recent one or two, and 2022 was the most recent incarnation. And the basic idea of this is to get about 20 people together, lock them into amazing surrounds in a room for 3 days, shut off their email, shut off their phones, shut off all distractions, and just get them to think extremely deeply about the grand future of robotics and research and the world. Sounds very grandiose, but it was pretty much that. And so what the format of this particular symposium was, one of the advantages of having run it a couple of times before is the format is relatively mature. So the idea was to structure deep dive discussions around 6 key topics. Learning is so important now in robotics that it got 2 sessions to itself, so there's a learning 1 and a learning 2. The other topics were simulation, action perception coupling, the environment, and applications. And so in the many months leading up to the summit, there were leads for each of these topics, and they were assigned the job of finding 2 really relevant paper readings to read, and also providing a statement on the state of that topic area. So that was all the pre-work. There was a lot of emails back and forth, some discussions, some meetings, and the idea is that you come to the summit and you're already in the right mental zone, and you're prepared to have some really good discussions. And so I went, this is in the middle of July, it was a long commute via Melbourne and Dubai. I know a lot of people are traveling a lot more now. There were queues everywhere, and so I would factor that into your travel decisions. Some airports I had to do 4 separate long queues involving bus transport, security, customs or immigration, and some other check. And this happened in Australia as well. The queue at Perth coming back into the country was almost out the door of the airport and no one knew what was happening. And someone pointed out one of the reasons there's such chaos is because the conditions are constantly changing, and so no one's settling into a standard routine, and that's why the airports are a little chaotic. I spent, because it's a waste to not do other stuff, I spent 24 hours in Munich. I mentioned this at a huddle, visited BMW, their amazing campus with 14,000 employees, and got to see not all of got to see some of their prototype vehicles driving around, which was super cool. That's one of them up there on a public road. Also visited Idealworks, which is this logistics company that's spun out of BMW, which has very strong connections to QUT. If you're interested in working in mobile robotics in Germany for a while, ask us and we can put you in touch with these people. But then I made my way to Berlin for the main robotics summit. So at the summit arrival, you could see a bunch of jet-lagged academics wandering randomly the streets of Berlin because it was very hard to work out where we were going. But I did see that Toby has a house in Berlin, which threw me off. One of the name tags had Toby's full name on it. And this was the summit venue, so you'd never guess these venues exist from the streets of Berlin, but you walk through this sort of alleyway and you popped into this amazing, the photos don't really do it justice, this amazing oasis in the middle of Berlin. There was a waterfall, a little waterfall, lots of different seating areas in this cobblestone yard, dappled sunlight coming in through the trees, the temperature was just right. Inside, there was a discussion area. This is where we spent the majority of the time. This really lovely old building with lots of artifacts, and the owner of the building said they only buy artifacts based on weight. So they have a minimum weight limit in terms of the decorations, and so everything in that was decorated in there was over a certain weight threshold, which is an interesting way to think about decorating your area. So this is my view for the majority of the 3 days. You can see this is in the evening or late afternoon session because everyone's got like a glass of wine or Prosecco or something like that. But there was lots of other breakaway spaces. There was a foosball table, there were comfy couches for discussion, including napping, because there was a few people who were a little jet lagged. Lots of different areas for impromptu discussions, really well done. Coffee machine, there was a full bar with beer and wine on tap as well, which is useful in the afternoon sessions. Catered lunches, there was even music, there was a guitar and a piano. So really set up to really facilitate really deep sort of informal interactions. So these were the attendees. So I think there were 22 academics, and you can see they're from sort of all the named universities around the world. So Georgia Tech, MIT, Stanford, EPFL, Oxford, Cambridge, etc., etc., etc. I knew just over 50% of the people there already, but there was about almost another half which I got to meet, which was fantastic. One of the reasons that the retreat was so interesting was they didn't just pick 20 people with great research records. They picked 20 people who would be good at a summit like this. So these were all highly experienced researchers who are leading their respective research fields. Their positions, they were all experienced, so there weren't any students, although the one that Nico and I will go to later this year will have students, but they're all assistant professors up to directors of major institutes like MIT, CSAIL, mostly academic, a few from industry. Disciplines, wide range of disciplines, there was learning people, a lot of learning people, control, localization, SLAM. There was quite a few bio-inspired people there, which made me happy because that's what I do, and they threw in one psychologist, which is an interesting addition. And everyone was very experienced in debating and conversing at a deep level, which is not always the case. And they mostly had deep knowledge of not only their own research fields, but of other fields like philosophy, of other disciplines. And there was a lot of quoting from history, from other areas outside the core technical areas, which really enriched the discussion. Another important thing was the egos were all checked at the door. And so unlike maybe a large robotics conference where everyone's sort of networking and some people are trying to sort of tell everyone about their research, there really wasn't any of that. So people's own research was brought up if it was appropriate, but no one was trying to sort of justify their presence there, and that makes for very different dynamics to what you'd have at a large conference. And everyone there was pretty sort of, I guess what you call is a secure, confident academic, and the reason that's important is if the debate gets heated and someone says something and someone else says, no, that's completely wrong, if you don't have a sort of mature audience, that first person can feel the need to just jump on the spot and defend their stance, but people were willing to let things go for the sake of the discussion, which is another critical part of why it works so well. And basically what this resulted in is this incredibly refreshing, invigorating 3 days of discussion, at least from my perspective, but I think most other people found it this way as well. So what was the summit? It was 3 days plus some additional bits tacked on. Basically, it was broken into 3-hour sessions on each of the 6 topics. And the way the 3 hours would run, there could be impromptu breaks, there could be breakout sessions. It wasn't rigidly prescribed what the structure could be, and it was up to the leads for each of the sessions, how they ran it. We had sessions inside, we had sessions outside, we had sessions at the bar, we had all variety of things. Every day there was a thing called a speaker's corner at the end of the day where anyone could get up and just rant about something, and that was also hugely entertaining and a great initiative. And then there was dinner or a function each night, and the discussion continued over dinner and sometimes quite late into the Each session had, the only people with a phone or a laptop out were a laptop scribe who was annotating all the notes from the session, and a paperboard scribe who was on big butcher's paper with colourful pens taking notes. And they were the only people. They were also directing questions because it got very boisterous, and they had to sort of make sure everyone had a go at answering or coming into the debate, because yeah, it got very animated at certain stages, which is great. I was a scribe for one of the sessions. I'm just showing this because I'm really proud of my improving from 0 artistic skills in terms of taking notes from the session, but everyone did a fantastic job. And I put all of this, rather than dealing with grant reviews or paper reviews, I spent a little bit of time rectifying all of this, and I stitched it into this nice mega poster. Sort of like Peter, I think, greatly enjoyed putting all the post-it notes from the retreat into a nice structured order. It's a very therapeutic process. And so you can see a large amount of notes, and there's also the paper notes as well, from this as well, from the laptop. All right, so I'll go through, and what I'm going to try and do is just touch on a high-level summary of the 6 technical sessions. Each technical session was 3+ hours, and I'm going to cover them in like 2 minutes. So it's just to give you a taster, incomplete taster, just to give you a feel for the sort of things that are talked about through these sessions. So, our learning 1 was all about models and data. And so what a lot of these sessions did, every session was different, but a lot of the sessions started with a deliberately varied range of provocative statements or positions in order to then drive the next sort of hour of discussion. And so position 1, and the people making these positions didn't necessarily agree with them, but it was there for the sake of driving discussion. And also I should emphasize that I'm probably going to do a bad job of representing fairly the opinions of everyone at the summit, but I'm the first person to do a summary of it as far as I know, so it's got to start somewhere. So they had a number of positions in the learning session. One, that if you've got enough data, machine learning is going to solve all of your problems, and we should all just stop our jobs or our PhDs, and the key is to make sure the data is sufficiently rich, whatever that means. Position 2 was we have sufficient data already, and we just need to add realistic, high fidelity, high throughput simulation to it, and then we'll solve all the aspects of intelligence and robotics easily. And position 3 was a little different, sort of factorized, pre-processed, appropriately curated data is the key. And these are not distinctly separate, they're overlapping conceptually, but these were the sort of positions that drove a lot of the discussion. So I'm already realizing I'm going to run out of time, so I'm going to go through this reasonably quickly. Some of the key concepts was separating out the concept of how competent and generalist robots are, a specialist robot that can do one thing, a trainee robot that can do one thing and then can be retrained to do one other different thing, and then a robot butler who is a generalist who can do most things. The word no priors is nuts came up a lot, so the idea that you shouldn't have to learn everything from scratch. I think I've heard people on this floor make that statement as well frequently. One of the things that really we kept coming back to through all these sessions is what is robotics? An existential question, which we never fully rectified apart from realizing we don't have a key definition of robotics. The reason it's important is it's distinguishing it and drawing boundaries between robotics and, say, computer vision and machine learning. One of the dominant themes that we kept getting tangented or sidelined back into is foundational models for robotics. So this is the idea that you have a massive corpus of data, probably multimodal data, and you throw a lot of brute force modern learning architectures at it, and you learn some fundamental aspects of knowledge representation and tasks or whatever it is, and then when you want to build specific robots that do specific things, you start with that foundational model and then you build speciality on top of it. That kept on coming, that probably dominated the discussion more than any other concept. We talked a lot about what is a reasonable level of generalization. So we talked about the fact that a snake robot's motion system, it's probably unreasonable to expect it to generalize to the motion system for a quadruped robot because they're so vastly different. So we talked about what is an actual aspirational level of generalization that's appropriate. We had lots of examples that anchored our debate. So one of them was, can we learn everything that a robot would ever need to know from just trolling the entire YouTube database? Lots of interesting debates that continued over lunch and other things about that. We talked about this brute force approach to learning versus program synthesis, where you're sort of have modular tasks and you're compositing them together. So that was learning 1. Learning 2 was more structured and more about the philosophical points. And once again, we had a few different positions just to generate discussion. So the first one was we should not be deploying robots that learn at all. All the learning should have happened before we deploy the robots, was that position. And then we spiraled into this sort of detailed discussion about what are the properties we want of safe, trusted, useful robots. And there's a list of properties there, particularly focusing on things like explainability and predictability. But once again, we didn't actually lock down these terms into concrete definitions either, because that's a very hard problem. The second position was the complementary position, which is we should deploy robots that learn. And one of the really interesting things here, at least from my perspective, I'm not a learning expert, was a very detailed discussion about the types of learning. So you might learn offline in a training environment to teach a robot how to do something. And then you deploy it, but you turn learning off. You might learn online in the wild. So in the deployment environment with your industry partner, the robot is learning. It might be a richer learning environment, but if it learns badly or does something badly, the consequences are much more significant. We talked about blended schemes, where you have a combination of learning across both of these modalities. Talked a little bit about cloud or federated or shared learning, where robot fleets are sharing what they understand about the world. Talked a little bit about during sleep, so a lot of biological systems are thought to consolidate memories during their sleep. And what is the equivalent for that for robots? Does it even make sense? The position 3, once again, not necessarily mutually exclusive to the other positions, was we must deploy robots that can be trusted. And the key concept running here was that we have to have a causal understanding, or the robot has to have a causal understanding of what it does and how that affects the world and the people around it. And one of the analogies, which is also interesting, is humans. So we talked about, and we didn't have any teenagers at the summit, so perhaps they were just being old and cranky. But we talked about the fact that people get their driver's license, sometimes with a few hours of training in a car, and then they are trusted to drive a 1 or 2 ton vehicle at 110 kilometers an hour everywhere. And that's very alien to the concept of what we put robots like autonomous vehicles through in terms of testing. One of the points that was made was that we have very strong cultural priors that enable that level of trust to be displayed, despite there being almost no testing of that person. Scarlett, I was thinking about your boat example, where the level of training required to get a boat license is arguably even less than a car, but there's a cultural prior there, which is very interesting. In terms of practical solutions, one of the things was letting the customer or the end user choose the acceptable level of risk and explainability for the robot, and letting that knob that you turn affect the raw capabilities of what the robot system can do, which is a really interesting concept. Talked about a per robot license to operate, so we have certifications and standards for robots, but maybe there's a per robot licensing system that might be applicable. That was another interesting concept. In terms of trust, the point was made, and this has been made in some of the defense forums here, that things are still going to go wrong when you have a verifiable robotic system, but you shouldn't be surprised when things go wrong, and that's a nice distinction to make. There's a lot of stuff about how do we do this. There was a nice quote that any prior belief, any prior knowledge will eventually be overturned by data. That came up quite a few times. We talked about a new concept called elastic priors, so I guess flexible priors, which is an interesting in-between case. And so that was the end of learning. But learning then continued to dominate the rest of the discussion for the week, and we kept coming back to it, and I guess that's why we did those sessions first. Simulation, there were 6 starting topics for the conversation. So do we need more benchmarking? What is the appropriate level of simulation to make robotics advance? The sim to real gap, which everyone complains about. What's the future of simulation? Like, what can we do in 5 or 10 years that we can't do now because of technology limitations? This would be of interest, I think, to John especially. How do we generate assets and tasks with the appropriate level of complexity to really be a boon for robotics? And the use of simulation to train or investigate these massive foundation models in terms of getting more data to train these systems. There's a lot of debate about this phrase, which has been widely used, which is simulation is doomed to succeed, and the tenor of the arguments was this phrase is less valid now than it was maybe 10 or 15 years ago, because we have much more realistic, much closer to reality simulations. This other quote is great too. All simulation is wrong, but some simulations are useful. I really like that one as well. And one of the things that sort of we had to clarify was that benchmarking and simulation are two completely different things. They overlap to some extent, but benchmarking and simulation are not the same thing. It gets mixed up a lot in the field. One of the specific technical examples, we had quite a few soft robotics people in the attendees, that friction, just the phenomenon of friction, is incredibly difficult to model for robots and not very technically feasible at this stage. We made the analogy that biological simulations, so a lot of what we know about neuroscience and animal behavior is done using ridiculously simple experiments where there's a rat or something in a square box, which has nothing to do with their actual natural environments, yet they've been able to make a lot of progress. And so there were some analogies from that. A lot of people chimed in the utility of simulation seems to vary hugely across disciplines. So Davide talked a lot about simulation being basically key to them getting high performance, rapid maneuvering drones to work for a number of reasons. Even a well-resourced lab like Davide's can't afford to crash hundreds or thousands of drones in real-world testing, so they need simulation. And we came to that point of simulation is one way you can actually make attacking and understanding foundation models vaguely feasible in the robotics space. In computer vision, maybe not so critical because you can just use data sets, but in robotics where you need interaction, much more critical. Action perception coupling, so this is all about the fact that robots act and interact with the world, and the world interacts with them. And so one of the key themes that they talked about, I'm not going to say the first word because I can never pronounce it correctly, so I'm going to say efferent copy. Basically, this is the idea of whenever you're controlling your robot, its actuators, you send a copy of the motor commands to the various processing systems rather than it just directly looking at what the actuator does, called efferent copy. And we talked about all the sort of processes where this might be useful, including tactile robotics, robot hand, robotic skin. Predictive control for drones has some overlap. And we did this really cool exercise, which would be a fun exercise to do here, and I was partnered with Ingmar Posner from Oxford. You got those objects, which you can see at the right of the slide. Someone closed their eyes and they had to open their hand, and the object was put in the hand, but you couldn't move your hand. And so the other person could manipulate the object and prod them, but this first person with their eyes closed had to guess what the object was. And then the second part of that study was the person who had their eyes closed, they could manipulate their hand so you could roll it around in your hand. And it was really interesting. We had about 20 or 30 objects, just totally random objects. It was really interesting the massive difference that being able to actively manipulate the object. Because passively people were doing the right thing, they were exposing someone to all the corners and all the objects, but the person who was being exposed to it had no idea what was coming next. And this is linking into that whole efferent copy thing. So very, very cool exercise. We also did a cool exercise with a high-speed projector, which I think had a frame rate of, 1440 hertz. And it was very cool in that you couldn't see anything on the projector, but there was actually a pattern moving really quickly. But if you, blinked or opened your eyes suddenly, you could suddenly see the pattern or the building or the image on it, just because of the way that your eyes are always saccading and moving little micro movements. So it was a very effective demo, and now I want a 1440 hertz projector, which is apparently just 12 120 hertz projectors stitched together with offsets. The example that I offered, which was also part of the discussion, was if someone skinned me and attached the skin of my skin fully instrumented to one of the robot hands, would that solve all of our problems as roboticists? And all the skin people and soft robotics people were of the opinion it wasn't just that, it was also the brain sort of skin connection there as well. The second last one was the environment, which is also interesting. And I got increasingly vocal as the summit went on because we got more to the applied end of things, environment applications and stuff. So the three questions were, how do we better leverage the environment to aid our robots? What is a robot and what is the environment around the robot? And that's a very interesting concept. And the third one was, what affordances does an environment provide for robots? This is the first time we actually had sort of, not equations, but some sort of mathematical statements. One of the concepts we talked about is the fact that really for enduring robotics, we want our robots to be able to endure in environments that change over time. So how do behaviors and policies of a robot change to adapt to the ever-changing environment? Do you try and come up with policies that are just robust to all types of environment conditions, or do they respond very sensitively as the environment changes? An example of this is autonomous driving. If the infrastructure around autonomous vehicles has sensors and other stuff, it augments the capability of the autonomous vehicle. So how does the behavior of the autonomous vehicle itself change in response to those changes in the environment? And then we got off on a whole segue because I love autonomous vehicles, but we managed to pull it back to the main discussion. One of the examples we also used was mining. So theoretically, you deploy autonomous mining vehicles in a mine, and they change the entire environment. You can't get more change than that because they start off with some earth, and by the end of it, none of that earth is there. And then there's all these intermediate steps. And so it's the ultimate example of a robot modifying the environment and then interacting with that environment as it changes. And things like, how do you make it so that there are access ramps for the robot in the intermediate stages of that process? We got back to spoons, so Anton van der Hengel from Adelaide would be happy. So one of the things we talked about was in any of the current robot systems, if there was a task where none of the cutlery in a kitchen was sufficient for purpose, but they would be sufficient for purpose if you bent it, like you could get a Franca Panda arm, and eventually, I'm guessing the engineers can correct me, eventually with enough time it would be able to bend a metal spoon, right? Just by bashing it repeatedly very softly. And we were talking about, can any of the current architectures in a non-contrived way genuinely adapt and learn that that is what they should do in order to get a task done? And the conclusion was probably not. Then another example was, duct tape that you use to fix everything. Can a robot learn inherently that it can do most things with duct tape and lubricant? That was another question that came up. All right. And then the final one was applications. We did this one outside. This was a big one. We talked about dull, dirty, dangerous, the sweet spots. Do we try and do what humans currently can't do, or do we try and do what humans can do but better or more efficiently? And we talked about sort of where the big opportunities were. Touched on ethics, societal impact, talked about economic sustainability. One of the things that was made, which is a very good point, is that we are probably inadvertently overselling the future of what robots will be able to do and underselling the current utility of robots. So for example, robots in logistics warehouses are still mostly invisible to the general population. Robots in drug discovery and other high throughput scientific operations, pretty much invisible, but serving fulfilling a great need. And then whether we're going to have autonomous vehicles in 5 or 10 years, we don't know. So this is a nice point, which I think is correct. I talked about equity of access and democratization of technologies, robot scientists being an increasing area, so robots that help scientific discovery in other fields. Robots for the environment was a big one, so I get to mention all the great stuff that the various groups here have done. One of the really cool ideas here, there were two cool ideas. One was using robots to deploy sensor arrays at global scale, so that you're not actually using the robots themselves, but they're deploying the cheap enduring sensor technology, so you have real-time surveillance of the entire atmosphere, for example, which is a really cool idea. The other idea was robots deploying these massive heat retention or heat rejection blankets as well. We talked about the great garbage patch as well in the ocean and robots potentially helping there. Talked about care robots, fall detection, improving the length of time people can stay living independently at home. And there was a strong argument there, like in logistics warehouses, like in mine sites, that you need to modify the infrastructure in order to make the automation feasible. One of the cool societal wins was if we managed to get cheap or effectively free robots everywhere, you might put people who indulge in exploitative or slave labor out of business, unless they're truly vindictive, because economically it won't make sense to exploit people, which would be a really cool outcome if you could do it. We talked about robots in like education, especially in highly marginalized education settings where someone is not going to school and is getting no access to education. Can they help there? A few other things. We talked about the benefits of applications shaping the research agenda as well. So the discussion continued sometimes quite vigorously into the evenings each day, which is really fabulous. If you don't know, this is Davide Scaramuzza. He's a star drone researcher at University of Zurich, but he's also a professional magician. And so every time he's at an event, we get the pleasure of watching him completely bamboozle us. So it's something to watch out if you're at a conference with Damodar. Speaker's Corner, this is that impromptu stand-up at the end of the day. We covered climate change, poverty, defense robotics, a whine or rant about deteriorating educational standards, which I think is universal on a few other topics. And we tried to keep the conversation grounded, so basically pointing out that there's been a lot of backlash against doing exactly what we were doing, which is a bunch of tech experts talking about how to fix the world. So we sort of went in with our eyes open, and we talked about the fact that poverty, like theoretically, you could do a lot to address poverty now with your current resources, so just throwing tech at it is not necessarily going to make any difference. So all the conversations took place in that sort of nuanced framework. We had a poster session with the local PhD students. They had 20 senior professors descend on their lab and grill them for an entire evening, which would have been a fun experience for them, but it was a really, really great show, lots of cool robots. And I got to see very briefly, I was jet lagged, so I got to go out at like 5 a.m. in the mornings and see a lot of Berlin, which I'd never been to. A lot of history. They have this amazing €9 ticket that gives you transport for a month. And I thought, hey, everyone must be using public transport now, but I looked up and they've done a bunch of studies, and making public transport effectively free has had very little effect on people not driving, which is an interesting outcome. Lots of history, went to the Berlin Wall and some other memorials, and got to eat some local food. Lots of cycles, lots of non-road-based, non-car-based transport, and some very clever retoolings of old buildings like bunkers to be these amazing new art galleries. All right, so key highlights and takeaways if you get hopefully invited to these events. There'll be a paper at some stage from this event. For me personally, it gave me a really good chance to reset. I'm now very much inspired, based on some of the people I meet, to dive into some other areas that I haven't been looking into. For example, collaborative learning with robots and humans. I'm starting to read there. I got to meet, consolidate, or strengthen links with a bunch of amazing researchers, but also got to meet some amazing new researchers, which is fantastic. And for me, it had this is a very personal thing, but this had this very strange effect where about a day or two afterwards, it felt like there'd been some permanent change to my brain. So for the last 3 or 4 weeks, I've been reevaluating everything I'm doing. It's just had this amazing effect. And I think it was not the topics that we discussed, but it was the act of being completely disconnected from any distractions for 3 days straight, which for me is basically never happens. I don't think I've done that for several years. And so it had these amazing on-flow effects, and it hasn't stopped for 3 or 4 weeks, which is annoying a lot of the people around me because I'm coming up with all these crazy ideas. But yeah, that was an unpredicted benefit of it. And I was jet lagged when I got back. I looked down and found out that I was having difficulties with basic cognitive tasks like pitching matching songs. All right, so that's it. Apologies for rushing through it. Obviously, it's very hard to do justice to such an in-depth event. But hopefully you get a little bit of a feel for how these events run and how I guess they're a little different to your standard big conferences.